Hi, everyone. Thank you all attendees who joined us today, and welcome to the ones who just had time to join us. Now, our fifth special keynote speaker. It is with special excitement that I'm welcoming Kemal El Moujahid. Kemal is the product director for Tensorflow at Google. He is passionate about solving big problems with AI and building vibrant developer communities. Prior to joining Google, Kemal led Facebook's virtual assistant, the Messenger platform, and with AI. Kemal graduated from the École Polytechnique and Télécom Paris and holds an MBA from the Stanford Graduate School of Business. So thank you very much, Kemal, for accepting our invitation. And please, the floor is yours.
Thank you. So hi, everyone. My name is Kemal El Moujahid, and I'm a product lead for machine learning at Google. I'm so excited to be here today. It's a fantastic initiative, and I'm really glad we're doing this event to grow the MoroccoAI community. So today I'm going to talk about how at Google we build ML tools to push the state-of-the-art of machine learning and then to flow this innovation into production to solve real-life problems. And these tools are not just for Google. We believe machine learning is changing the world, and we want to help make this technology accessible to everyone. Now, why is making machine learning accessible so important? I will start with a special story. It's about the Great Barrier Reef in Australia. Reefs around the world are facing a number of threats like climate change or pollution or overfishing. The Great Barrier Reef is threatened by the overpopulation of starfish, which you can see on this video, which destroys the coral tissue. This can lead up to 90% coral destruction, which is a natural disaster. So to control the starfish population, first, we need to locate it. But the reef is huge. It's like 350,000 square kilometers, which is comparable to the size of Morocco. So to locate the starfish, the traditional method involves divers dragged by boats, manually counting the starfish. Now, we know that this is a problem that machine learning can help with, thanks to cameras and computer vision models. And solving this will have a huge positive impact on the planet. And this is why making machine learning accessible matters. It allows people around the world to work on these kinds of issues. But how do you do that? How do you empower millions of developers to solve the world's most important problems? With platforms which can bridge the gap between world-leading ML experts and developers who are passionate about a use case. There's more to say about the Reef story, and I'll get back to this later in my talk. So now let's get into ML at Google. As we know, three factors power the ML revolution: data, lots of data, compute power, lots of chips, and advanced ML models. And these three elements have each increased in orders of magnitude. So how do we harness the power of these three elements? This is where ML at Google comes in. TensorFlow in particular is behind all AI-powered products at Google, from search, YouTube, Pixel phone, cloud. And we made the decision to open source TensorFlow and share these advances with the world. Open source is a very important principle at Google, and we believe AI advances faster if we open source our technologies. So today there are thousands of users all over the world building amazing AI applications with TensorFlow. This is the latest map of the GitHub stars for TensorFlow, and you can see it's in every time zone in the world. TensorFlow has had massive adoption, and we're seeing the usage grow and accelerate. We have hundreds of millions of downloads. There are 1 million learners enrolled in our courses on Coursera and Udacity. So on behalf of the ML team at Google, a big thank you to all users and contributors who've helped build our community. We have a variety of users in various fields. In research, TensorFlow is used to predict extreme weather. This is the Summit computer made of 27,000 NVIDIA GPUs, which is basically 2 tennis courts. And their model passed the quintillion computation per second mark and opened the way to better understanding how the climate works. Businesses are also improving their products and services on mission-critical systems with TensorFlow. So for example, Twitter uses TensorFlow to rank tweets for their users. So if you're using Twitter, TensorFlow is what works under the hood to show you tweets you might be most interested in. We also build other tools like JAX and TPUs, which DeepMind used to solve the 50 years grand challenge of protein folding, which will open incredible new applications. These are just a few examples of things that people have built using ML tools at Google. So let's get into a few of them. So at Google, we build an ecosystem of products to enable research, flow this research into production, deploy models everywhere responsibly, and then we democratize ML by building a community around these products. First, let's look at how these tools are used to push state-of-the-art research. So many fields of research require dealing with unprecedented scale. And Google TPU is a piece of hardware that is managed in the cloud and deeply integrates with TensorFlow. It's designed from the ground up to accelerate deep learning workloads, both for training and serving models. Those TPUs can then be arranged in pods. And when you have hundreds of those chips connected together, they form an AI supercomputer. This scale allows researchers to build incredible new models, like T5X. T5X is a modular composable framework for sequence models, mainly language, at scale. The T5X model shown here uses transfer learning to convert every language problem into a text-to-text format. The model has over 11 billion parameters. And that's just one example of how our tools are being used in research. And we welcome you to try it for yourself through our TPU Research Cloud program. You can join the thousands of other researchers who have trained models on cloud TPUs for free. We want to make this computing power more accessible around the world and provide everyone an opportunity to try their ideas on state-of-the-art hardware. Another really interesting new research I'd like to share revolves around indoor navigation. Imagine you walk in a house and you've never seen before. And just from a few pictures, you build a system that can infer the structure of that new space. And not just the space he had seen, the space he hasn't seen, dream about it. As we can see in this video, Path Dreamer is able, from just a single observation of an environment, to create high-resolution, 360 degrees observation up to 7 meters away from the original location, including around corners. PathDreamer is being built using TensorFlow and Keras, and is now fully open source, so you can check it out at the link on the slide. A framework we're starting to see a lot of traction in research recently is JAX, a Python library designed for high-performance numerical computing. Here's a sample of what JAX code looks like. It looks like a program with regular Python plus NumPy. What's cool about JAX is what you see in the last two lines, where your code gets accelerated on GPU or TPU with no additional change. And JAX libraries are composable with TensorFlow. So for example, you can use TF data to feed data into JAX. Now the next step is to flow this research into production. This involves providing simple building blocks that ML developers can use to build their production systems. From your first and simplest machine learning model, you can use the high-level API from Keras. But you can also use the same API to do pretty advanced things, like, for example, understanding why computer vision models determine what they see. Here, we use class activation maps, and we can verify that the way the model determines that this image is a cat is by paying attention to the cat's face, which is a good sign. As you can see, Keras is great for getting started, but also to do pretty advanced things. And for that reason, we believe it's the best framework for applied AI. And we've been hard at work improving Keras. In TF 2.4, we enabled Keras models to support training on TPUs, GPUs, and clusters of multi-GPU machines by simply switching the parameter of their distribution strategy. In TF 2.6, Keras preprocessing layers were released, making it much easier to add preprocessing capabilities to your models. We've also modularized Keras as a separate pip package on top of TensorFlow, which will make it much easier for the community to contribute to the development of Keras. So next in the toolchain is TensorFlow Hub, a great way to get started with pre-trained models, so you don't have to start from scratch. On TensorFlow Hub, you can find hundreds of pre-trained models for video, image, text, speech, and audio. For example, here's a simple model we trained for comment spam detection. You can find it at Hub and then test it very easily. Or this bird detection model, where we can upload a picture and get it classified immediately. And of course, when you want to use the model to solve your business problem, you don't have to do it by yourself. TF Hub will show you how to do it, which layers to freeze, which ones to use for activation, etc. Now, once you've trained a model, it's time to deploy it in production. And when we want to do that at scale, we discover that workflows are typically more complicated than pushing just one model. So at Google, we've measured that the ML model code to be something like 5% of the total code necessary to train and deploy the model in production. All the other tools and infrastructure that you see here are critical. So how do you manage such a large operation? Well, for that, we offer TFX, an open source solution for the entire problem of machine learning operations, from storing and pre-processing data to model validation. Amongst many other places, TFX is orbiting right now in space. Airbus built an AI system trained using TFX to detect anomalies on the International Space Station in real time. Anomalies in space can be lethal, and identifying them in real time can be life-saving. So this is literally mission critical, and they chose TFX to do that. And for those of you who need a fully managed service, you can find all these tools on Vertex AI, a new platform on Google Cloud to help you accelerate experimentation and deployments of AI models. Vertex AI has tools that span the entire developer workflow, from data labeling, notebooks, and models within a single console experience to prediction tools and continuous monitoring. Now, one of my favorite features is AutoML, which automates model training so you can build sophisticated models faster using tabular text, image, or video data. Another great aspect of our ecosystem is that we make it easy to deploy your models everywhere. The number of edge devices continues to increase, and they're also becoming more powerful, which makes it possible to build new amazing ML-powered apps. First, on the web, Include Health uses TensorFlow.js to enable remote physiotherapy at scale while maintaining the user's privacy. Here, we see that MoveNet's single-person detection model is used to provide feedback on the form of the exercises. We also recently launched a new multi-person detection model. This model not only detects multiple people, but also tracks them. So here you can see two people switching positions, and the tracking still works. So imagine what you can now build with a simple web page and a camera. And on mobile, a great way to get started is MLKit with easy-to-use, production-ready turnkey APIs. From barcode scanning to language identification, MLKit offers simple cross-platform building blocks, which run well on low and high-end devices, and they're totally free to use. Now, for more advanced developers, we offer TensorFlow Lite. TensorFlow Lite powers all of Google's mobile apps, as well as popular external apps on more than 4 billion devices. And finally, we also offer a library for running your models on tiny microcontrollers. With TensorFlow Lite for microcontrollers, you can run ML models on hundreds of billions of microcontrollers with only a few kilobytes of memory. Now, as we deploy these models, it's very important to do so responsibly. A typical machine learning workflow will look at something like this. But there are many moments where going through your development workflow that you should be asking yourself these types of questions. Who is my system for? Are there any privacy consideration when collecting my data? Are there real-world or human bias in my data? Where do I get relevant features in a privacy-preserving way? Are my test users diverse enough? Or should I even deploy my model? These questions are important because fairness and privacy concerns may be experienced differently in different product types. So we have built many tools to help you answer these questions, and you can find them on a dedicated portal at this URL. Finally, I'd like to talk about the most important part of what we're building, and that is the community. Our machine learning GDEs are at the heart of our community. They give tech talks, they organize workshops, and they can help you get started. One GDE whom we gave special recognition during our community day is Sayak Paul, a Google developer expert who has been very active in our ML community. He's made contributions to models and tutorials in TensorFlow Lite, and a tutorial for dual development on Vertex AI. So I really want to thank again all of our developer experts for their amazing contribution. Another great way to contribute is by joining a TensorFlow user group. We have 87 user groups spanning 37 countries, and they hosted great activities this past year. Now, speaking of TensorFlow user group, I want to give a special shout out to Sarah, Abdulrahman, and Abdullah, who launched the TensorFlow user group in Casablanca. This is a picture of a meetup I attended 3 years ago when they were just thinking about launching this group. I'm personally very happy to see what they have done. I find their example very inspiring, and I encourage you all to join their group. Now, another great way to connect is to join the TensorFlow forum, sharing ideas and best practices with each other. I would love to see more Moroccans join the forum. We want to build a vibrant community where anybody is welcome and can learn machine learning. That's why we invest in education. And I'm super proud to see that we've passed the 1 million learner mark across our online courses. Now go check out tensorflow.org to explore all the books, the courses, and videos that are available to help you ramp up your skills. We also have an annual program of faculty awards to support machine learning courses, diversity, and inclusion. But this past year, we've gave grants to 40 universities in 20 countries to help them develop new machine learning classes. And when you're ready to showcase your skills, you can take our certification exam. Now, a year ago, we launched the TensorFlow Developer Certificate. And since then, more than 4,000 developers from over 80 countries have been certified. You can then share your expertise with the world by displaying your certificate on LinkedIn, GitHub, or the TensorFlow Certificate Network. Now, I remember discussing this very idea in our meetup in Casablanca 3 years ago. So I'm really excited to see this coming to life. And this works. We're hearing great feedback, including Tia, a certified TensorFlow developer who re-entered the workforce after years of being a stay-at-home parent. Another great place to learn and showcase your skills is Kaggle. Kaggle has amazing resources for ML learners. For example, check out this notebook written by Kaggle Grandmaster Andrada Olteanu. She details all the practical resources and routines that have helped her grow from a beginner to Grandmaster in less than 2 years. It's an amazing resource. So as you saw today, there are many ways you can connect, learn, and contribute. And we work together with members of the community so you can all build and have impact on the world. Now, I want to close out with my initial story, the Great Barrier Reef. As I mentioned, ML can help with locating the starfish population more effectively. But what if anyone could help build the best model? Well, we have just launched a Kaggle competition, so you can try to build a model that will help save this natural wonder. So I will now play this video.
Australia's Great Barrier Reef is the world's largest and home to a wealth of undersea life. Unfortunately, the reef is under threat from climate change, fueling the overpopulation of the crown of thorns starfish, which can devour living coral at a devastating rate. To give the reef time to recover, Australia's National Science Agency, the CSIRO, and Google are scaling up from traditional surveying methods like manta towing to a machine learning platform to identify and count the starfish. We want your help to build a TensorFlow model to accurately detect starfish breakouts in time series images. TensorFlow engineers will work with the CSIRO to optimize and deploy the winning model, which we intend to open source for the scientific community to help control coral-threatening starfish populations around the world. Join the challenge today to help us protect the Great Barrier Reef so we can build a better world for generations to come.
Pretty cool.
It is very cool indeed. So that was really an amazing talk. Thank you very much, Mr. Kemal, for an enlightening and entertaining presentation on Google Machine Learning ecosystems for research and production. Many thanks to you for accepting our invitation, and we will see you actually very soon in the panel, so in a while. So many thanks to you. See you in a while.
Thanks for inviting me. Bye.
See you. Bye-bye.